All right, let's look at something interesting about water. Water is said to be amphiprotic or amphoteric. Yeah. So aside water, we also have HCO3 minus and HSO4 minus. We have other species there as well. So what is amphiprotic or amphoteric? Amphi means double life. Protic has to do with proton. So let's mix water with water, and let's see what we are going to get. Yeah, so water is seen as H plus combining with OH minus. So this one is going to lose H plus to this, and is going to form OH minus, and this will gain H plus to form H3O plus. So this water molecule was donated a proton. So it behaves as an acid here. This one accepted a proton, behaves as a base here. So you can see water acting as an acid and a base. So it is amphiprotic or amphoteric. This species also do same. If HCO3 minus, yeah, let's assume we put it in water. What is going to happen? If you put this in water, what is going to happen? This is going to donate the hydrogen to this. Yeah, this is going to donate a proton to the water molecule, and it will form CO3 minus, 2 minus, and the water becomes H3O plus. Also, it could have accepted a proton from the water. Water will now protonate it, and to become H2CO3, and the water becomes OH minus. So, as you can see, the same species donating a proton, here accepting a proton. So, amphoteric. You can do same for this one. All right. Then let's look at the strong acids. Strong acids. So I'll give you a list. There are about 7. If you see an acid which is not part of the list, that acid is going to be a weak acid. We have HCl, HBr, HI, H2SO4, sulfuric acid, HNO3, nitric acid, HClO3, and HClO4. So these are the strong acids. If you have any acid which is not here, then it's a weak acid. So take note of it. Then we have the strong bases. We have sodium hydroxide, we have potassium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide, like this. These are the strong bases. So if I give you any other base which is not here, then it's a weak base. All right. So let me give you H2CO3. It's a very weak acid. It's not here. It's a weak acid. Weak carbonic acid. Ammonia NH3 is a weak base. It's not part of the list. A weak base. Not part of the list. Weak acid. CH3COOH. Ethanoic acid. Weak acid because it's not here. So that's how we are going to do it. So take note of the strong acids and the strong bases. Now, this is carbonic acid, weak carbonic acid, or let's say ethanoic acid and HCl. HCl is strong, ethanoic acid is weak. Now, in water, both of them are going to what? Have the same strength. So you call it what? The leveling effect of what? Water. One is strong, one is weak, but in water they all exist as H plus. One is strong, one is weak. In water they all exist as OH minus. This is what we call the leveling effect of water. No matter how strong you are, no matter how weak you are, in water you all are the same. All right. So let's look at these acids. HCl is having one proton, as you can see. This, that. They are having one hydrogen. But look at H2SO4. Yes. So let's take HCl. Let's take HNO3. Because they're having one proton or one hydrogen or one acidic proton, we say they are monoprotic. H2SO4 is diprotic. H3PO4 is triprotic, in that order. So polyprotic. If you have two or more hydrogens, then you are polyprotic. But if you have only one acidic hydrogen, then you are what? Monoprotic. So let's look at how we can calculate pH of monoprotic acids. In fact, let's see how we can calculate pH of both strong acids. We'll come and look at what? So pH, we have pH and pOH. We'll come and look at the weak acids aspect. So how do we calculate pH? First of all, we are going to start with water. We should know, let me put water, aqueous. We should know something called this H++ OH minus. Ionic products of water. Ionic products of water. Ionic products of water. Kw. Yeah. Kw has a value of 1.0 by 10 to the power negative 14 at 25 degrees Celsius. Yes. So water is neutral. So anytime you have water, concentration of OH minus ions and concentration of H plus ions are equal. When you multiply the ions of water, yes, so ionic product of water, we are going to get that Kw, which means concentration of H plus, square brackets means concentration, times concentration of OH minus should give us 1.0 by 10 to the power negative 14. Yeah, so that is it. Which means that if you are given concentration of OH minus of a solution, to get the concentration of H plus, you use this and then you divide. Yeah. So when you take negative logarithm of both sides, you end up getting pH plus pOH equals pKw. So keep this. Then what is pH? pH is equal to the negative logarithm of H plus concentration of a solution. We know that H plus will be the same as H3O plus since they both represent acidity. And pOH is equal to, so P of anything is negative logarithm of that thing. So pOH is negative logarithm of what? OH minus concentration. pKw means what? Negative log of what? The Kw. So how did I arrive at this? This is it. This equation here, I took negative log of everything here. OH minus equals negative log of Kw. And then what did I do? I expanded negative log of H plus negative log of OH minus equals negative log of Kw. I did it because if you're having log A plus log B, it is going to give you log AB. So since here they are multiplying, meaning I have to change it to plus. So negative log of H plus concentration is what? pH. Negative log of OH minus is pOH equals negative log of Kw is equal to what? pKw. Yeah, and we know Kw to be 1.0 by 10 to the power negative 14. So let's take that negative log of 1.0 by 10 to the power negative 14. If you input it into calculator, you get 14. So pH plus pOH is equal to 14. In our next video, we'll look at some examples how to calculate the pH of strong acids. How to calculate pH of strong acids and pH of strong bases.